Do you know how Russia just shocked the world with what they're building? They're creating something far more dangerous, and almost nobody is talking about it. It's not just another hypersonic test or recycled propaganda clip. What you're about to hear isn't smoke and mirrors, it's the outcome of a strategic tech revolution happening right now inside Russian military industry, energy institutions, and high-priority state scientific labs. This is the unseen push that most global headlines barely mention, but it could change how nations prepare for war, sell energy, control key resources, and build future weapon systems. Stay with me through the next few minutes, because what you'll learn next will show you how these technologies actually work, why they matter geopolitically, and what the world isn't ready for yet. Start with a simple truth. This isn't hype. The Kremlin state armaments plan through 2027 to 2036 explicitly calls for the wide use of innovative technologies, including artificial intelligence, across strategic forces, space systems, air defense, communications, electronics, warfare, unmanned and robotic systems, and weapons based on fundamentally new technologies. That language is policy, not marketing. It directs budgets, procurement, and doctrine, and it signals that Moscow is aiming for architectural change, not incremental upgrades. When we peel back the headlines, three practical patterns emerge and intersect: mass and attritability, speed and surprise, and economic industrial lifelines that sustain technological scaling. First, mass and attritability. Instead of betting on one exquisite, expensive platform, the strategic idea is to make many cheaper, expendable systems that achieve effects through numbers. You see this in the drone story, long before specialized missiles. Moscow doubled down on producing huge quantities of small strike drones and loitering munitions designed to be used en masse. That's a deliberate calculus. If you can overwhelm defenses with sheer numbers, the value of any single defensive asset falls dramatically. Independent reporting and battlefield analysis show this production scaling and the doctrine around attritable swarms. It's a manufacturing and tactical shift at once. Second, speed and surprise. Hypersonic systems like the Oreshnik change the timelines decision-makers face. These aren't slow testbed launches. They compress detection, attribution, and response windows into minutes or seconds. When hypersonic delivery is combined with AI-assisted guidance and adaptive sensors, you have a weapon class that not only arrives faster, but can adapt mid-flight to countermeasures and choose evasive trajectories. That dynamic matters for deterrence, defense, and diplomacy because it forces opponents to reconfigure early warning, interception doctrine, and crisis protocols. Recent confirmed uses of Oreshnik and reporting about deployments into Belarus illustrate how Russia is operationalizing these systems, not merely demonstrating them. Third, industrial and economic lifelines. Rosatom's continued foreign reactor projects and other state export channels matter strategically. These energy and infrastructure deals tie recipient states into long-term technical partnerships that bring in Russian standards, personnel, and long supply chains. Money from export sustains R&D and production. Technology exchange creates resilience against sanctions. And the presence of Russian technical teams abroad creates soft leverage. Rosatom's plans to bring multiple reactors online in 2026 across different countries underline how energy tech is a diplomatic and industrial lifeline that's deeply relevant to military technoscaling. Now let's look at how AI threads through all of this, because AI in the military sense is rarely just one thing. For Russia, AI shows up as perception stacks for drones, so cheap aircraft can identify targets semi-autonomously, as adaptive electronic warfare systems that jam or spoof sensors, as logistics planners that keep supply moving under attack, and as command-level analytics that forecast adversary moves from noisy, incomplete data. Policy papers and expert analysis show Russia explicitly building institutional capacity to fold AI into armament programs. That institutional coherence is what turns isolated prototypes into operational systems. That institutional coherence also allows risk-tolerant operational models. Where Western procurement often glacially moves from prototype to approved fielding, state-led models can iterate under combat conditions, accept losses, refine designs in theater, and scale production quickly. That's not a guarantee of success. Performance gaps and reliability issues persist, but it shortens innovation cycles. Battlefield use becomes a kind of accelerated R&D lab, and Russia's current approach shows it is willing to run that cycle in public, which is why analysts see innovation mixed with significant limitations. Let me give you a concrete battlefield picture. Imagine a coastal theater where hundreds of small drones, each cheaper than a smart missile, are launched in waves. Some are kamikaze types. Others are swarms that spoof and jam coastal radar while a subset homes in on high-value electronic systems. Simultaneously, hypersonic missiles compress response times for strategic targets inland. Under that scenario, defenders face layered problems, saturation of sensors, too many targets to track, and shrinking windows to decide. Add AI-enabled command tools that recommend firing solutions, and logistics is that reallocate resources automatically, and the human decision loop becomes compressed into a system where trust and timing matter more than ever. This combination is precisely the strategic logic Russia appears to be pursuing. There's also the hybridization of commercial tech and military kits. Obvious examples include the repurposing of consumer drones, using cheap satellite bandwidth for control and ISR, and exploiting global supply chains for components. The result is faster diffusion of capability. The time from concept to field use shortens when parts and software are commercially available and when open source tools are repurposed. That complicates attribution and sanctions enforcement because the enabling technologies are widely sold and legally ambiguous. Analysts note how both sides in modern conflicts derive advantage from marrying commercial economies of scale to military requirements. Cyber and electronic warfare are equally critical. AI augments both offense and defense. Automated red teaming tools can probe networks at machine speed, while defensive AI can triage and patch in real time. For Russia, which has long invested in cyber capabilities, AI creates a force multiplier. It means faster exploitation of vulnerabilities, automated deception campaigns, and more adaptive jamming. Defenders respond with AI-driven intrusion detection and automated remediation, and the result is a new, faster contest in cyberspace where response windows are measured in minutes or seconds rather than days. There are practical constraints and vulnerabilities to stress as well. Russia's industrial base, while sizable, still depends on specialized components, advanced semiconductors, precision machining, and certain materials that are affected by sanctions. Moscow has invested heavily in import substitution and alternate procurement routes, and its energy export partnerships help monetarily and technically, but gaps remain. That's why you see the combination of scaling cheap systems, drones, with focused high-end projects, hypersonics, and why some capabilities advance unevenly. Sanctions and supply constraints shape what can be produced at scale and what remains rare and expensive. What about doctrine and governance? This is easy to miss if you only watch weapons parades. True change comes when organizations rewrite rules about who can authorize autonomous functions, how AI is certified for battlefield use, and how responsibility is assigned when an automated system errs. Russia's state armament guidelines and institutional reorganizations show a push to integrate AI into doctrine, but the speed of that integration can outpace ethical and legal frameworks. That raises the risk of miscalculation and accidental escalation because automated systems interacting at machine speeds can produce outcomes commanders did not intend. International norms and governance remain immature relative to the speed of development. From a production and workforce perspective, Russia is mobilizing talent through state centers, industry consortia, and university programs focused on military AI and advanced materials. The state-led model can direct graduates, research labs, and industry toward priority projects with centralized funding and procurement. That creates speed but also concentrates risk. If a single choke point fails, a foundry, a specialized design bureau, or a reactor component plant, whole programs can stall. Observers watch both the mobilization of talent and the fragility baked into concentrated supply chains. Now pause for a moment and imagine the geopolitical consequences. If a nation pairs credible hypersonic strike capability with massed autonomous swarm systems and deep energy export partnerships, it has a new toolkit. In theaters near its borders or in regions where it exports reactors and infrastructure, that nation can project power through a mix of kinetic options and soft technical dependence. Competitors must respond with new defenses, different alliances, and altered procurement that prioritize resilience and distributed production. This is a strategic problem set that mixes technology, economics, and diplomacy, and it is precisely the configuration the world should watch. So what should viewers take away? First, the headline story is incomplete. The danger isn't a single weapon. It's systemic, an interconnected approach combining massed autonomous systems, speed-focused strike capabilities, and economic levers that sustain technological continuity. Second, sanctions and export controls matter, but they are not a silver bullet. Diversified partnerships and import substitution can blunt some effects. Third, governance and doctrine lag technology, and that gap is where risks of miscalculation and accidental escalation lie. If you want the next deep episode, I'll walk through one program in particular, a covert logistics and unmanned maritime system that analysts think could change naval logistics, and I'll show the leaked procurement lines that hint at hidden supply routes. Hit subscribe Mind Facts and I'll drop that full investigation next. For now, remember this: what Russia is building is not a single showpiece. It's a new model of power, industrial, electronic, and automated, and the world hasn't adjusted to that reality yet.